All right, let's look at the next lesson in Unit 12, arc length. So we've looked at arc measures, how we found the measure of the arc is equal to the central angle. Now we're going to talk about the arc length, which is a portion of the circumference. Circumference, remember, is the distance all the way around it. Excuse me. Now we're only looking at part of it. And so we use this letter L to represent our length. The X is the central angle, excuse me, which is also the arc measure. So when you hear the measure of the arc, that's going to be the angles. How many degrees is it? And then we have the radius. So our formula here for the length is going to be the number of degrees, which is our arc, times the circumference, divided by 360. So we're finding kind of the percentage of the circle that's covered here with our circumference and the given radius. So let's take a look at how this works. We're going to work the odd ones, and then you can go back and work the even ones if you'd like. And check your answers. They'll be posted in the completed notes. So find the length of each bolded arc in terms of pi and to the nearest hundredth. So just in case they ask for either one, you know how to do it. So the first thing we're going to locate here is x. X is going to be the 107. And then our radius here is 6. So we're going to next find the circumference, which is going to be 2 times 6 times pi. So we're going to go ahead and get this as 12 pi. Now we're going to plug it into our formula. So we're going to have the arc length is equal to the x, which is 107, times 12 pi, divided by 360 degrees in a circle. So how many degrees overall? Now, you always want to look for ways to simplify before you multiply. So if you add up 1 plus 7, that gives me 8, and that does not qualify for any of our divisibility rules. But I do know that 12 goes into 36. That means that 12 is going to go into 360. So we're going to mark that out. And it's going to go into 360 30 times. So that becomes now on the bottom becomes 30 instead of 360. So now we can write this as 107 times pi over 30. So that is an exact answer in terms of pi. And then we get our decimal equivalent, and we're going to get 11.21. This will be meters. So this is going to be in just a single unit here. So there's meters this way. So we're going to get 107 pi over 30 meters, which is the same thing as 11.21 meters. That's how long this length is compared to our full circumference of our circle. All right, let's take a look at the next one here. So now they give us one that has 142 degrees. We have 4 centimeters of radius, so we're going to say our x. Now, we're looking for this dark arc, so that is not going to be it. So we have to do 360 minus the 142 to get our arc. So for how many degrees this is, we're going to subtract, and that's going to give us 218 degrees. So we do 360 minus 142 to get 218. Our radius is 4, so therefore circumference is equal to 2 times 4 times pi, which is 8 pi. So now we're going to find our arc length. Arc length is equal to 218 times 8 pi divided by 360. So we look to see, can we cancel or simplify anything that if possible? We know 8 goes into 360. It goes in here 45 times. You can find that by dividing. Now, 218, if you add those up, that becomes 11. That's not going to be one of our divisibility rules. We know it's not going to end in 5, so 15 and 5 is not going to go into it. And since it doesn't apply to one of our divisibility rules for 3, so 3 is not going into it, so we can just multiply it out and get 218 pi over 45. So this is an exact answer in terms of pi. This would be centimeters. And our decimal equivalent would be to multiply by pi and then divide by 45, which is going to give us 15.22 centimeters. So that is our both answers in terms of pi and our decimal. Moving on to number 5. So once again, we're looking for the length of each bolded arc. Now, so it doesn't say bolded. We don't have a bolded arc here, but it does tell us CD, so we're going to bold it here. So we're going to look for this arc right here, CD. Now, we know this is 68 degrees. So we know our x here is going to be 68. We need to identify our we have our radius here of 15. So we need to identify our circumference, which is going to be 2 times 15 times pi, which is going to give us 30 pi. So circumference is 30 pi, and this, of course, is in centimeters. These are in centimeters, and this is degrees. So to find our length, we're going to do our circumference, or our degrees, arc measure, times 30 pi divided by 360. So we look to see what can cancel. We know that if we take the 0 here, they both cancel. 3 goes into 36 12 times, so we get 12 here. Now 68 is even, 12 is even, so we can simplify this down a little further. And we can say 4 goes into each. We know 4 goes into 8, so it's going to go into here 3 times, and 4 goes into 68. Let's see here. That would be, what is that? 68 divided by 4. Let's look here. Oh, I see a mistake already. So let's go back and fix this real quick. Got the wrong numbers here. So I found BC and not CD, so let's go ahead and erase that there. We're looking for this arc DC. So we're looking for this one. So because these two are supplementary, because BD is a diameter, we're going to subtract 180 minus 68. That's going to be 112. So that means that this arc is 112 degrees, which means that I need to go change this over here as well. Looks like the problem was a total fail. So, but we can always recover, which is what we're going to do here. So we got 112 times 30 pi over 360. So once again, this is going to cancel with this, giving me 12. And since these go by 2, this is going to give me 6 here. That's going to give me, let's see, we can actually go 4. Let's go 4 here. This becomes 3. This becomes 28. And so now all we have left is 28 pi over 3. This would be in centimeters. Now, that's our length. Now, that's exact answer. So now as we do 28 times pi divided by 3, that's going to give us approximately 29.32. And we're able to recover with your teacher's mistake. So, thank goodness we caught it early. All right. So let's go try the next one. You can try number 6 on your own. You'll be able to check the completed notes to see if you got it right. Let's look at number 7. So VS, that is the full diameter here, is going to be 12, which means that this has to be 6, and this is 6 here. But because we can use our formula here, using pi times diameter, circumference can be pi times diameter, which means our diameter is 12, so this becomes 12 pi. Now, the next part here is we need to identify our arc UT. So this is going to be this arc from U to T here. So we need to figure out what this is going to be. Now, if this is diameter, this is diameter here, that means the vertical angles, which means this whole arc from U to S would be 127. And if this part is 90, then we would subtract from 127, which would give us 37 degrees. Let's see if I did my math correctly in my head. Yes, I did. So 37 degrees is what we're looking for. So X is going to be 37 in this case here. So now length is equal to 37 times 12 pi divided by 360. And there we go. Again, 12 and 360. We know 12 is going to go in here 30 times. And now we look to see, does anything go into 37? And it does not. So the length is 37 pi over 30. That's our exact answer. This would be in meters. And then our decimal equivalent would be 37 times pi divided by 30. And that is going to give us approximately 3.87 meters. Let's look at number 9. You can do 8 on your own. Let's go to 9 here. FG is 27 yards, so that means my radius is 27. So circumference is equal to 2 times 27 pi, which is 54 pi is our circumference. The arc is FED, so starting at F, going through E, and all the way to D. So it's going to be all the way around this except for the 47 and 80. So if we do 47 plus 80, that's going to give us 127. So we'll do 360 minus 127. That gives us 233 degrees. So 233 degrees is what we're looking for. Our x is equal to 233. Now, let's do the arc length. We're going to get 233 times 54 pi all over 360. And we look to see 3 goes in here. That's actually going to be 18 goes in here 3 times. 18 goes in here 20 times. And then nothing can go into 233, so we're going to get 699 pi over 20. And the decimal equivalent is going to be 109.80. So there's our 2 answers in terms of pi and as an exact answer. Or in terms of pi and our decimal answer. All right, so let's move on to here to number 11. A couple application problems here. A 16-inch pendulum swings through an angle of 40 degrees. How far does the tip of the pendulum swing and travel? So if you think of a pendulum here, it's got a fulcrum here, a point here. And what this does, this pendulum hangs down, okay, and we'll say it just, put another dot here. It's going to hang down, it's going to swing. So what it's going to do, it's going to swing back and forth. Okay, and as it goes back and forth here, that's the path it's going to take. So let's say that if we took this and drew a line from here to here, this becomes, these act like the radius of our arc here. So a 16-inch means this is going to be 16 inches here, it's going to be 16 inches here, 16 inches here. So we only have to worry about with one of them, but 16 inches as the length of this pendulum. So it's going to cover this distance here. So it wants to know how far is this going to travel. So what is the length that's going to travel here? And it's going to swing at an arc of 40 degrees. So this is 40 from here all the way to here. That is our 40-degree arc. So it means our x in our problem is going to be 40 degrees. So we need to know what part of the circumference of this. Well, we know the radius is 16, so circumference is equal to 2 times 16 times pi, which is going to give us 32 pi. And now we're going to take and plug it into our length formula. So we're going to find the length here. We're going to get 40 times 32 pi divided by 360. So just to make this problem a little easier, we'll simplify it. We know 40 goes into 30, or 4 goes into 36 9 times, so it's going to make it 9 here. And then 32, there's no number that goes into 32 and 9, so that's going to be 32 pi over 9. So now we're going to just multiply this out, which is going to give us approximately 11.17 inches is the length that it's going to travel. Once again, you only have to simplify this if the problem asks for it in simplest in terms of pi. So you'll need to make sure you leave them as fractions as well. All right, let's look at number 12, the last one here. A car entered a roundabout from Mason Avenue, traveled about 280 feet, then turned into Perry Street. If the roundabout has a diameter of 150 feet, find the angle of rotation to the nearest degree the car has traveled. So what we're looking at here, so you know a roundabout is a circle. Okay. Now, we have a point here in the middle here. We're going to, that'd be the center of our roundabout. Now it says that it's has a diameter here. So if we have this diameter here, so draw this across, that's going to be 150 feet. Okay, so that means that our circumference here is going to be 150 pi. So as we round this out, we know it's going to travel. So let's say it's only traveling from this point here to this point here. So we're going to say it travels around our circle, and it's going to travel 280 feet. So that's the path it's going to go. And so that gives us our total length. So that is actually the length here, 280 feet. So we want to try to figure out what is x. That's what we're trying to find. So we're going to do our formula. Length is equal to x times the circumference divided by 360. So we're going to plug our numbers in. We're going to have the length of 280 equal to x, which we're looking for. Circumference we know is going to be 150 pi divided by 360. So as we solve for x, we need to start getting rid of everything that's on the same side as x. If we put this over 1, we can see clearly what we need to do. We can cross multiply. So we can do 360 times 280. So as we multiply this number, it's going to be a large number. 100,800 is equal to x times 150 pi. So now we need to get rid of 150 pi. So we're going to divide both sides by 150 pi. That cancels this, leaving us with x by itself. So this is going to be our number of degrees. And so when we plug this in and divide it out, we're going to get 213.90 for x. So that says round to the nearest degree. So that means x is going to be approximately 214 degrees that this arc is going to travel. So this would be, of course, this is not drawn exactly right. Of course, I drew from here. So this means this arc right here is going to be 214, which means it's 214 out here, which is not actually correct because, of course, it would be somewhere over in here. Okay, but for the purposes of working the problem, the numbers work out. It's going to give us 214 degrees. So this concludes our lesson on arc length. So any problem that we did not work, you can go back and work and check your answers in the completed notes.